Hey, it's Alex Williams, founder and editor-in-chief of the New Stack, and we are here at KubeCon plus CloudNativeCon in Seattle, and I have some members of the Oracle team here who are going to talk with me about container lifecycle management. So I just would like to make some quick introductions. Andrew Pride is a principal software engineer at Oracle. Hi, Andrew.
Hello.
TJ Fontaine, software engineer and consulting member of the technical staff at Oracle. Hello, TJ.
Hello.
Monica Riccelli, product manager at Oracle.
Hello.
And Kiri Filipovsky, a cloud architect with Oracle.
Hello.
Thank you for joining us. I'm always interested in where we are today because it speaks so much to where we've come from, obviously. And lifecycle management actually, has a long, deep, rich history. How is the traditional view of lifecycle management compared to the container approach that we're seeing? In many ways, it was manuals to such an extent that you really had to think about the product management. Now, we're talking about distributed architectures, and a lot has changed. So I'm just curious on anyone just to talk about that perspective, about how they view lifecycle management compared to its roots.
I'm kicking it off?
Yeah, you're going to kick it off. You had the company that got sold. So.
Sure. So there two main differences, I would say, from historically how lifecycle management has been done, right? So the containers themselves are a new sort of type of resource compared to previously, which was VMs or whatnot. So the one aspect that changed is how the domain model looks like in terms of the infrastructure being represented with containers and whatnot. But to me, even more important change is the design concepts and the architectural approach to Kubernetes with the containers is very different than what was there before. The whole concept of model event-driven orchestration is something that was not really prevalent before. Most of the stuff before was workflow-driven automation with a lot of steps and sort of human imperative way to approach to lifecycle. So I think that to me is the bigger difference is the lower level Kubernetes aspect of how it approaches the problem.
So go ahead.
I mean, I think a lot of it boils down to the kind of declarative versus imperative way of looking at the world, doesn't it? And that suddenly we find ourselves confident that the constraints on our systems are being enforced the entire time rather than one and done. You run your workflow and hopefully you get to the end and hopefully it stays there for as long as you want it to be running.
Monica, what have been the effects on from your point of view on this transition to more container lifecycle focus?
Yeah, we see drastic changes in our customers. So I'm a product manager for WebLogic, so we have a lot of customers that have large enterprise deployments of WebLogic, and it has really changed not only the operational, but the time to deploy their applications on Kubernetes. So I have one example of a customer that it used to take, let's say, 30 minutes to bring up and deploy their entire WebLogic domain, and now it takes just 2 minutes to do so. Once you have, the container of WebLogic. We also see big changes in high availability because of the self-healing characteristics of Kubernetes. Starting pods when they become unhealthy. We also developed an operator, WebLogic operator, which also, extends Kubernetes to help us manage that deployment and life cycle of the WebLogic servers in Kubernetes.
So TJ, what makes Kubernetes model work well for managing the container lifecycle management process?
Yeah, so what really, I think it's what everybody said here, that model allows everyone to increase their velocity for all of these aspects. So you can focus on getting to the business logic and focus on adding value to your team and less on all of the rest of the operations that you've spent all of the time building all of your idempotent workflows to figure out how to make all of that work before, where there was tons of effort being invested in that part. Now you can focus on just what I need to be reacting to this event, moving forward, react to this event, move forward, much how we deal with the rest of our lives as well.
How does that affect your teams?
I view that as freeing for our teams. If somebody feels differently, they should tell me. They should have told me before we got on the podcast. But I think it makes us. We can focus on where problems are impacting us and improve that specifically, and be able to move forward from there. And I remember going in the initial conversations with WebLogic Operator how we were going to be able to provide value for customers on Kubernetes and make sure we were understanding that. And they were able to really pick. These are the use cases that are hard today with WebLogic without Kubernetes. Here are the things that we can focus on making faster, time to delivery being one of them. And I think that was really powerful for the WebLogic team to be able to come into this new ecosystem and it was really fast for you guys.
Monica?
Yeah, absolutely. So we see that it reduces the time for operations and management, and it can be dedicated on the development. Also, the portability that is offered in Kubernetes, of our deployments is greatly improved, and it makes it much easier with Kubernetes rather than like on-premise, for example. So it resolves a lot of difficult problems that our customers have by running on Kubernetes.
Kiri or Andrew, how has that affected your work, this new approach?
Well, I mean, I guess we're providers, so we're kind of not your typical, in one aspect, business application developers. We're basically developing software for other developers or for other engineers. So there is a lot of the aspect of kind of using your own tools. I think it's one of the unique things in what we do is because it allows you to sort of understand the domain that you're solving the problem for and then kind of start developing for that. So that's kind of pretty cool. We use our own tools, obviously, that we build and all that. But in general, I mean, the impact is on any development team is obviously significant with this transformation, and everything is changing all the way up to the commit, basically, about all the processes that stem from there.
And I think it's key there that you're packaging up that specialist knowledge about managing and running information systems, that you can have someone who deeply understands that domain model making those decisions and then provide that in a repeatable piece of software that customers can take and deploy, and their teams don't have to worry about the minutiae of how is my database backup going to be performed, how is that self-healing, etc. And that instead of worrying about building these kind of bespoke systems, that we can now build and package these operators to solve problems, a whole class of problems for a wide range of customers, rather than having to kind of everyone specialize their own deployments and workflows.
Monica, could you talk to us a little bit about that operator model that you developed?
Yeah, so we developed the WebLogic Kubernetes operator to extend, of course, the Kubernetes operations to manage the whole, from the creation to the configuration, to the management of all Kubernetes resources required to support the WebLogic deployments. So that greatly simplifies the deployment of complex WebLogic applications in Kubernetes. Our customers are very interested because they have all these traditional applications that they have on premise, and they want to move it into Kubernetes, and the operator just makes it so much simpler for them, from the point of the creation of the WebLogic deployment to the configuration, management, to even the end cycle, right? The maintenance, the life cycle of every server in the WebLogic deployment.
So TJ, Kubernetes is an open source project, and how do you manage that inside an organization that has tens of thousands of developers? And I mean, is this where you started?
Hire more lawyers. No, So actually, when we started working towards this effort internally for we wanted to highlight an open development model for all of our software stack as well. So everything that our teams work on largely is open source from the get-go, and that's why it was our group that's spearheaded becoming a CNCF Platinum member to do all of that, so that we could have actually kind of a blanket approval to commit and work on anything in the CNCF space. So that means that we can work on Kubernetes and all the related componentry, and we wanted to really focus on that. And that was both, to self-serving so that we could get more developers and engineers that wanted to work with us on interesting things, but also to contribute back to this community more specifically on all of these things. So and it spans a variety of generational technologies, right? We have WebLogic, and that's being done in the open. We have MySQL, which is very much still a very powerful cloud platform for people, as well as a research and development angle of how can I model more than just my software with Kubernetes. What if I were trying to model my actual IaaS with Kubernetes? So that we've been trying to take all of that, but we wanted it all to be out in the open and transparent for everybody to see the kind of work that's going on inside of our group.
Andrew, how's that affected your work?
I mean, it's brilliant as a developer to be out there and engaging with the community, sitting on Kubernetes SIGs, and really engaging with the open source community to find what the needs are. And as an individual, the work you do when you work for large companies often sits behind the firewall, so to speak, and that individual recognition and visibility from your peers in the community isn't there. But when your day job is there working on a project on GitHub, and you're getting direct feedback from your users and from early adopters, it really motivates you to write the best software that you can and to solve those problems.
So, Kiri, in terms of the teams and the workflows that you've established, and then using the technologies to build these architectures, what have been some of the efficiencies, some of the improvements that have provided you the capability to extend deeper? That seems often a effort that you see on behalf of organizations building scaled application architectures.
Well, I think the real world is kind of a little messier than normally what you hear.
So I'm told.
So generally, when you're in a real software team and building, the application is quite complex. It's going to have some legacy components. It's going to have some container components. It's going to have some serverless components, and there is a sort of like a common thread when you're managing that whole thing. You're really managing your application. You're not managing containers or infrastructure or serverless or anything like that, right? So there is an opportunity, I think, for the Kubernetes community to kind of look at it from that angle and then try to understand the potential of Kubernetes in terms of solving the problem from that aspect. Then you're going to find out that Kubernetes is more than capable of stretching its legs, if you will, beyond containers and trying to address some of those standard management lifecycle problems that exist in a real world type of scenario, if you will. And I think whether that's going to come from the community itself in terms of extending it because they have a real need, and you can see a lot of the enterprises here are contributing controllers, using CRDs, extending them, which is where I think the sustainability of Kubernetes is going to come from, is really that openness that allows the enterprises to kind of solve real world problems on top of a good core engine that exists out there. And we're doing that as well. That's kind of one of our points of view, I guess. So
one of the questions I have is about container lifecycle management and how it's a change for the customers too. And the container lifecycle management, we hear about application lifecycle management. I think there's a similarity, right? When you think about that, when you're thinking about Kubernetes, the architecture really does have to take into consideration the storage and the networking and the security issues that are much deeper in the stack. But you have to make it abstracted to a sense for those developers so they don't necessarily have to think about those issues. How do you think about that? How do you balance that?
Well, I mean, picking up on what Kiri was talking about, one of the things that we've been doing specifically with the OCI Manager that we open sourced this week is actually trying to work on those abstractions that allow you to, say, address your cloud in terms of compute, storage, and network in an abstract way. And then you can have implementations specific to, your on-premises cloud or, what you're, a traditional public cloud. So you can do all of those things and you start to abstract those for them. But you want to keep the abstractions approachable for the development teams so that you can make sure that they're still focused on, I'm here to build my application and do that, and then the other teams that are supporting them, the platform teams that are supporting them, can fill in the details of what it means to provide that security and that level. Because I think you would struggle to be able to get development teams and engineers to be able to understand the implications of all of their decisions, across the entire stack. It's not that they shouldn't be ignorant of what their decisions are; they should still be very much aware of them. But I don't think, to Andrew's point before, I don't think you can expect everybody to be a domain expert in every one of those things. So you need to be able to fill in those abstractions with details and provide models for them. And that's really kind of where we've been pushing things. So that's why you're more than just specifying your replica set or your deployment. You're describing your persistence layer for your database, and then you're describing your application with your WebLogic, and then potentially you're abstracting all of your IaaS constructs, be it IAM, be it the virtual network and its security lists among all of these things, and you're using the same interface, and that by using the same interface for all of those actions, everybody's playing on an even field and understands how to interact with each other.
How do you then make that a developer experience that that is manageable for people?
I think Kubernetes provides us with a set of building blocks and API best practices that really, almost for the first time, enable an understandable and very literate definition of what I expect it to happen and what my resources are, and that as we see custom resources being defined for things like MySQL databases, like WebLogic, and many more across the conference floor, what you see is that these all have the same structure, they have the same feel, and as a developer, instead of having that kind of fragmented experience of having to understand the nitty-gritty details of this is how MySQL is configured, or this is how any other product is configured, they can very quickly understand what a Kubernetes resource looks like and have that familiarity across a wide range of domains, which allows that kind of abstraction and that ease of use.
Kerry?
Let me jump in on that. So in terms of simplification or exposure from a developer perspective, and kind of, it's one thing to have the coverage to be able to manage quite a bit of what the underlying dependencies is. It's another thing to be able to understand and actually manage them. So obviously the solution, an immediate solution there is to use templating engines like Helm and KSON and whatever, which drastically simplifies. But a shout out there to the operator type, because I think that the operator is really where you get the simplifications, because what it does, it gives you a autonomous composition underneath the operator with heavy dose of the machines doing the heavy lifting in terms of doing the low level resource management in a manner that's contextual to your application, whereas the developer simply specifies very few overrides that the developer needs to do. So there's a bit of difference between templates and operators. You can get started with templates, but eventually where we think it's going to make real benefits in terms of simplifying for developers would be higher level operators. But obviously you have to have the low level stuff on the control plane to be able to build the operators that are comprehensive, that'll cover every single aspect of your application.
Yeah, so for right now it's still YAML, but we're just trying to reduce the amount of YAML for right now.
That's right.
Right, we find that in, like for example, in the WebLogic operator, all the complexity of security and resource management, we provide it to the operator, and we allow the developer to provide some inputs through YAML for that operator to then take those inputs and manage the resources underneath, and not face the complexity of security or resource management to the developer. and we find that that's what our customers want, right? They want that separation.
Yeah, and I think one of the things that I've noticed with all of the different operators is that the operators that are successful have kind of bucketed together a few really common configurations for their applications that they're focusing on, and then those are just one knob that you're tuning that says, hey, it's going to look like this, it's like this, it's like that, and it's not the formerly, WebLogic and MySQL have tons and tons of configuration and knobs that you could go do, but that's not going to fit. It's the 80-20 rule, right? Like we're really targeting the 80% for that, and that's how you kind of reduce the complexity of thinking about each of these things, and then it's all open source. So at the end of the day, if they need a knob to tune, then they can crack it open and fix it.
And also, the important thing there is also to expose the extension points. So in the MySQL operator, you will get a completely functioning, highly available InnoDB MySQL cluster straight out of the box with very little tuning, and through your custom resource you can tune a number of parameters. But if you want to go down, dig right into the weeds, you can still provide your MySQL configuration, and you've got that extension point. So it doesn't have to be that once you get to that kind of 80% that you suddenly have to throw it all out. That it's critical, and Kubernetes itself has shown this, that you define extension points for these systems to allow them to be flexible enough that it's not a case of it just solves the simple use case or even a few use cases.
What was it that Oracle open sourced this week?
So OCI Manager was one of our biggest open source announcements this week, which was basically, I'll intro it, Kira, you can fill in more details. It's basically a way to express the Oracle Cloud Infrastructure, it's our IaaS offering at Oracle, as Kubernetes custom resources, and then with an active reconciliation of so you submit what you want the cloud to have, and then Kubernetes essentially ensures that it's always in the cloud for you.
Yeah, I mean that's pretty much it. It's an attempt to try to extend Kubernetes a little bit to the levels below with Direct. Obviously, with the intent that some operators will actually help you sort of consume the IaaS layer in a more developer-friendly way, is with whatever extent that an organization or a team wants to use that. But yeah, it's pretty much taking that new conceptual approach of desired state, actual state reconciliation to the IaaS layer, and then see where there's some sort of value to be had over there. So that we open source that. It's a pretty straightforward project. It's out there on GitHub.
I think one of the interesting things about it is, like, if you think of a world where you have the OCI Manager plus the MySQL operator, you could be orchestrating with the same kind of operator on containers, or potentially orchestrating bare metal instances, which is an interesting part of that. It doesn't just have to be orchestrating Kubernetes, and I think that's kind of what we were trying to show the community today.
You're trying to show the community that
Kubernetes is more than just containers, or can be more than just containers.
Right. There's value there.
So the concept of operators is relatively new. We heard about it, last year, Copenhagen. There was discussions about it. It's still so nascent. That what are the areas that you're focusing on from an open source perspective to help build out the operator model? I imagine there must be some gaps that you're thinking about that need to be further. You need more maturity, more development.
So the folks at SIG API Machinery, the Kubernetes special interest group that is kind of spearheading a lot of this stuff, are making excellent progress on things like versioning and really starting to think about, okay, we have the building blocks here, we can define our resources, we can write controllers, but how do we now manage the life cycle of this software going forwards? How do we evolve this in a way that keeps the same properties that Kubernetes has of lossless conversion between different versions of resources, better validation. All of these things are really making the operator experience a first-class citizen in the Kubernetes ecosystem. So that kind of stuff is very exciting to see.
Okay, I think why operators are interesting is they really solve that day two problem, what they call it, right? It's I mean, creating certain compositions from day one is sort of the easy part of the problem. It's when you get to the service, when it's out there, day two, year one, year two, and you have to do upgrades, and you have to do, those are the hard problems, right? And I think this is where the operator provides an opportunity to solve those harder problems on an ongoing basis throughout a longer term life cycle of application. Now that's just saying that doesn't really, there's still quite a bit of challenges in terms of how do you actually structure the operator. People still create the logic in the operator in terms of how people used to do these things, day two, like how do I upgrade, some application, how do I kind of make sure that it's live and all that stuff. So I think the operator kind of gives another angle as well, where you kind of have a machine doing it, and you have to kind of design it in a way to think about, okay, it's not really a person that's doing the upgrade, it's the machine. So there's more creative ways to solve that day two problem. But in general, that's what the effect or why we like operators is, because it solves the hard problems.
And from last year to this year, we also now have the operator framework that's came through CoreOS, now Red Hat / IBM. I mean, if you can follow that history, that's out there. That's actually making it a lot easier for people to adopt the operator pattern and just kind of take more sub patterns of operators and say, oh, this is my problem fits in this niche. I'm going to fill in these details over here and there, and so that's really powerful and will accelerate operator creation in the ecosystem. But some of the other gaps that are happening there is the WebLogic operator is actually written in Java, whereas most of the other operators are written in Go, and so that's a gap. Not everybody writes everything in Golang, and there are varying reasons. Sometimes you have an existing business logic that you want to reuse for your operator. So for some of those things, filling in the details of different languages and addressing the rest of the ecosystem would be really helpful for increasing operator adoption.
Yeah, I agree with the two things that were said. Resolving these complex problems of upgrading applications with a zero downtime. So those are very complex problems that our customers want resolved, and that's where the operator pattern can come in and help with the upgrades, with the versioning, support for different so we went through the process of deciding, okay, should we write it in Java, should we write it in Go? And the decision was made because most of the knowledge of the engineering team was in Java, and we didn't want to spend the time that it would take for them to ramp up and learn it in Go. So of course we sometimes are subject to waiting on availability of certain Java APIs, but once we have already created it, right, it will continue to be written, and so maybe some other tools around the operator will be written in Go, but the operator will continue to be Java in our case.
I see. So for the year ahead then, for the operator model to continue to thrive, what's the work that needs to be done in 2019, do you think? What are just a few things on the top of your mind?
I think TJ is right. The operator framework and Kube Builder as well, which has come out of one of the Kubernetes special interest groups. These are really important developments because the amount of code when we wrote the MySQL operator, for example, that is involved in bootstrapping these pieces of software is very much non-trivial, and the more that we can simplify and abstract that away and allow companies to provide operators for their own software, because that's where the power is. Companies know how to deploy and manage the software that they build, and that's why it's so important that we develop the MySQL operator, the WebLogic operator, etc. And so what we really need going forward is yes these improvements in Kubernetes itself, but also it's about the ecosystem and about really reducing the amount of effort it takes to develop operators so that we can be open to a wider audience.
And how will that affect lifecycle management then?
So it's gonna change. I think we're already seeing inside of Oracle a change to adopt this model. I think that's going to change how a lot of Oracle properties are thinking about service delivery in the cloud and on premises. So I think that's going to be great. And moving forward in 2019, there's some really important details that need to be filled in. I think we'll probably see a broader adoption of serverless as it relates to operators. Right? We're talking about an event-driven model that today are a bunch of long-running processes sitting listening to Kubernetes for events. We'll probably see that operators start acting more like serverless endpoints. But I think, and this is true for all of Kubernetes, and it's a hard problem. It's not really solved. Identity as it relates to operators and identity inside of Kubernetes still needs to be fleshed out further. Right? There are special interest groups around the notion of pod identity. So you need to understand all of these pieces, and cloud providers need these things to have identity as well. This is really a common question when I'm talking to service teams about running on top of Kubernetes. They want to be able to figure out how they can secure their workloads, and how do I know that thing that's communicating with me is what I scheduled it to be. And that's a lot of those kinds of conversations, and I think that'll come out of the community hopefully this year. I'm anxious for that.
Well, I want to thank you all for your time speaking today here at KubeCon CloudNativeCon. It's exciting to see what you're doing. There's a lot of thought put into this, and a lot of interesting development. So, thank you for coming by, and we look forward to talking to you soon.
Thanks for having us.
Thank you very much.
Thank you.
That last point is interesting about the serverless as an endpoint.